Welcome to episode 334 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm all right, Rob. How you doing?
Doing all right. Yeah, still cold. Still cold down here. I'm sure it's even worse in Denver. I saw your tweet about the temperature differential.
What is it? An 80-degree temperature differential across like 25 miles or something like that. Yeah,
which is crazy.
It's Colorado. It's funny because in that tweet, like if you go and read, because that was a National Weather Service tweet.
Mm-hmm.
And all these people are responding to the National Weather Service saying, you need to check your thermometers. Clearly, this is wrong. Where those of us who have been living in Colorado for more than a few years are like,
no, it's normal.
Yeah, this happens. Like, this isn't even that surprising. I mean, particularly
nice to know that, you could just drive 80 miles and get a bit warmer if you like to.
Yeah. I mean, well, part of the problem with that particular one was there's no direct route between those two locations because the mountains got in the way, which is why it was possible for there to be such a large temperature differential.
That makes sense.
But either way, I mean, I was chatting with one of my friends and he was 10 degrees warmer in Denver. I mean, I say that I'm in Denver. Technically, I'm just outside Denver. Like 10 degrees feels pretty, it's a lot warmer.
Yeah, definitely. All right. Well, at the top of every episode, I like to read a piece of feedback. We got this tweet from Daryl referencing last week's episode with Kobe, where we were talking about using Docker. He wrote, yep, eliminating system CRUD when doing the dev is so nice. The missing implicit dependencies show up much quicker. And yeah, that's definitely something I don't think we talked about, but yeah, if you are running from a Docker container that only has the specific, components and tools that you put into your container script Docker file, then if you're missing anything, you're going to have to go and add it to the container and you're going to know exactly what you need.
That's a good point. It kind of makes me feel old because I've just been so used to using full VMs for that for so many years. Actually, guess I should try using a container at some point.
Yeah. And I should mention that when we had Kobe on last week, we actually had like a whole bunch of other topics we meant to talk to him about, and we just spent so much time talking about Docker that we didn't really get to it all. So we're probably going to have him on again real soon to talk about some other things.
Yeah, it's the first time we've ever done that.
Yeah. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Brian Kernighan. Brian received his PhD from Princeton in 1969 and was in the Computing Science Research Center at Bell Labs until 2000. He is now a professor in the Computer Science Department at Princeton, where he writes short programs and longer books. The latter are better than the former and certainly needs less maintenance. Brian, welcome to the show.
Hi, guys. It's a pleasure to be here.
That's, I mean, there was so much happening in Bell Labs at that time. That had to have been a very exciting time to have been there.
Yeah, it actually was kind of remarkable. I mean, some of this is the rosy glow of it being a long time ago, but I certainly remember it as being one of the best times of my life, where you're surrounded by a whole bunch of good people doing really interesting things in a field that hadn't been mined out or gotten too commercial, or all just all kinds of benefits like that. So a golden age, at least as Filtered Through said, rosy glasses.
Well, I mean, to be fair, I have jobs from 20 years ago that I don't think of as the best time of my life. So it's not just the rosy glasses of time, hopefully.
Yeah. All right. Well, Brian, we got a couple news articles to discuss. Feel free to comment on any of these, and we'll start talking more about your work at Bell Labs and UNIX and C and all that good stuff. Okay. All right, so this first one we have is a blog post from Andreas Vertieg, and this is more than a year of virtual classes experience, the good parts. And he's going into his experience with teaching, doing virtual training for C++ during COVID times over the past 2 years. And, there certainly are plenty of advantages that he goes into, like it makes everything a lot more accessible. You can easily join a Zoom call and not have to, pay to travel to some location to attend a class or anything like that. Yeah. What do you think of this, Jason? Because I know you've kind of held off on doing any virtual training.
I have, yes. And reading it, I feel like my style of teaching classes is different enough from Andreas's that I don't know if the advantages that he sees would directly have applied to my classes. Because like if I don't get interaction throughout the class, then I don't have that much lecture material. I need people interacting with me. Where the advantage is that Andrea says, well, if someone is ill or needs to go do whatever, then they can just turn off their camera and chill and still listen.
Right.
But I'm like, well, I need people participating. Otherwise, my class is going to be half as long as they signed up for, basically.
Brian, what are your thoughts on this as a computer science professor? Have you been teaching virtually this whole time? Are you getting back into like a hybrid or in-person style of classroom these days?
It's been, well, close to 2 years of this. And for about, the first year or thereabouts, it was entirely virtual. And that was, as Jason suggested, really most unsatisfactory. I think anybody who teaches does a much better job when there's an audience where you can see whether you're getting across. You can see the places where you have completely not gotten across. People ask questions spontaneously that send things in often new and interesting directions. And so all of that stuff doesn't work nearly as well when you're on Zoom or some equivalent of it. And so I found the level of engagement a lot lower, I think, with kids when I was doing it via Zoom. The other thing is that if a class gets too big, you can't see them all. Period, even. And, although the rules are you're supposed to leave your video on in practice, there's times when you can't and times when you don't want to. And so, no, I think the downsides certainly outweigh the upsides a lot, aside from the scheduling issues. I mean, the fact that I can talk with you folks without leaving the comfort of my office right here in beautiful suburban frozen New Jersey, that's a benefit. And I've given talks in Australia and Argentina in the last couple of weeks, and that kind of stuff would never happen in previous life. So that's the good bit. Scheduling is often easier, and it was certainly easier when kids were locked down. The class I taught, a year ago last fall, I guess, had kids as far separated as England and Hawaii. And so there was a noticeable time zone gap in that. And that was, clearly a nuisance for all concerned, but something that was part of the equation. So, yeah,
that's interesting.
We're back to, at this point, in fact, we're last fall, full in-person classes, but everybody is tested. Kids are tested twice a week, and I'm tested once a week, and everybody wears masks and has to have been boosted, no exceptions. And so that means that it is, comparatively safe in a real sense, and it's a lot better. I like the pace when I'm in class, back and forth and back and forth. Probably drives the kids nuts, but it's better, and so I can do that kind of thing again. So, yeah.
Any issues with teaching in a mask? I have.
I was wondering that too.
Yeah, my brother-in-law's wife is a professor, and she had to get a mask with a window on it because she had someone who was hard of hearing in their class. Wow. Just to be able to read lips, the mask was getting in the way. Yeah.
Oh, that's a new one on me. No, I haven't had that. The thing that I found when I first did it was that you need to inhale as well as exhale. I had trouble with that part of it, and so I was always gasping for breath.
I'm curious, what classes are you teaching this semester or last semester?
So last semester was a class that I've done almost every year for over 20 years at this point, on computing and communications and things like that, but for a very non-technical audience, history major kind of people or English majors and things like that. And so I did that last fall. I did it the year before, totally virtual with 20 kids. I did it in person, 30 kids last fall. And that was absolutely fine. It was nice to be in the same room as the kids. In the spring, I've been doing independent work seminars. Princeton has this requirement that kids do independent research as undergraduates at various amounts. And so I've been running a couple of seminars with sort of 9 or 10 kids each on digital humanities, which is kind of a off-the-wall topic if you're a hardcore computer science stuff. None of this Docker bit, but at the same time, it's a lot of fun, and a chance for kids to explore an area that they might not otherwise have a chance to explore as part of an academic experience. So I've been doing that in the spring for the last 3 or 4 years.
Very cool. Okay, the next thing we have is a post about Bolt being merged into LLVM to optimize binaries for faster performance. I don't recall, Jason, if we've talked about Bolt before, but
I feel like it may have come up once, but I wasn't sure.
I was not sure either, but it sounds pretty impressive. It's something that was developed by Facebook, and it's been used internally there for a while. And it is used to optimize the code layout for binaries generated from GCC and Clang. And it's now going to be part of LLVM. And they have some nice graphs here where they're showing like the performance improvement that you get from Bolt alone versus performance improvement from PGO. And you can combine them to get even more combined performance improvement. So looks like pretty great stuff.
If I'm reading this right, like you take your binary, run it through Bolt, and it does an optimization of the layout, and magically GCC is 21% faster. Like,
that's great. Yeah.
I was hoping you guys would tell me. I assume it has something to do with cache management. Is that what the deal is?
Part of it looked like cache layout. Yeah. I mean, for cache advantages, layout for cache advantages.
Yeah. Okay.
The closest corollary I can think of in my own work is when I've used profile-guided optimization incorrectly. So code that was in the hot path in the real world wasn't in the hot path during PGO. So then the compiler and linker takes the code that wasn't in the hot path and moves it to the far end of the binary. And then anytime you need to call that code, it has to do, a jump to a code that's cold, not in the cache, load it into the cache, and then execute it. And so by running profile guided optimization incorrectly, I was actually able to get like a 30% performance hit to my application. So if it's a similar kind of situation, but it's relaying things out to make sure the code that you're always going to execute next as much as possible is hot and ready to go, then maybe that's where it gets its big advantage.
Yeah, this is really, now that I slightly understand it better, it reminds me of something so far back in my past. I did my PhD thesis on a problem called graph partitioning, and the original impetus for that was to improve the paging behavior of programs by figuring out which chunks of code, let's call them subroutines or functions, went on particular pages so that you minimize the number of transitions from one page to another, because that would cause a page swap.
That sounds like it could be almost directly related. They should, maybe you were referenced in their paper. I
don't think people go that far back.
I knew to know some computer science, much younger computer science professors, that it surprises me sometimes. They're like, well, everyone already did this research back in 1965 and we're just now rediscovering it,
All right. And this last thing we have is a post on hacking CPP. And this is cheat sheets. And there's a whole bunch of different ones. We have cheat sheets for algorithms, sampling distributions, a whole bunch of stuff in this page. Looks like it's really good for reference.
I've had this page open for like 2 months and kept meaning to put it in the show notes. I thought it would be a good one to add in today. It's just the author put so much work into showing all these graphs for how the algorithms execute, how data is laid out with all the different types in the standard library and everything. It's an incredible amount of work.
Yeah, definitely. Brian, I did want to ask, what is your kind of current language experience like? I mean, obviously you had a lot of involvement in C. Are you keeping up to date with C or C++?
Not in a strong sense.
Okay.
In C, I basically tuned out of the improvements after roughly the 88 version or something like that, when a lot of things got added, none of which were of any direct use to me, and so I kind of zoned out. C++, I follow pretty casually. I hate to admit it on this particular August forum.
That's fine. No, yeah.
But the other hand, Bjarne is a very good friend, and he and I talk quite regularly, and I get sort of bits and pieces about the standardization process. I have read manuscripts of, I think, all of the C++ book over at this point 40 years. So in that sense, I kind of keep up loosely, but I haven't written any significant amount of C++ for 6 or 7 years at this point. So I know what it is. I recognize it when I see it.
Right.
But I think if I look, most of the coding I do at this point is pretty small stuff. A lot of it in service of explaining something in a class, and for that it tends to be either awk for one-liners or Python for things that might be a couple hundred lines, and that's about it. Occasional forays into other stuff, but not much.
I didn't even think about that until just now. You and Bjarne must have overlapped at AT&T for a while, huh?
Yeah, I guess the way I would phrase it is that I was at Bell Labs. I arrived there permanently in '69, and Bjarne arrived there in '79 or '80-ish, approximately. And through the luck of the draw, I was his manager, although you don't manage people, for, I don't know, close to 15 years. And then he went off to AT&T Labs in roughly 95-ish or something like that. But we stayed in close contact all along.
Oh, that just shows how terrible my history of these things are. I didn't realize AT&T Labs was a separate lab from Bell Labs.
It was one of the fission products when AT&T split in 95 or 96 into Lucent, which was sort of the bulk of the old Bell Labs, and AT&T Labs, which was the part of it of AT&T that went. Yeah, Bell Labs, the Western Electric, the manufacturing stuff, and so on went one direction, and sort of 2/3 of Bell Labs went with that, the part that I stayed in. Another third of Bell Labs went with AT&T, which at that point was basically long distance kind of communications.
Right.
Okay.
And in various ways, all of the fission products fell on hard times.
Okay. Well, Brian, maybe we should start off by talking about this memoir that you wrote, which is about the development of Unix. What kind of inspired you to write this 50 years after the original development of Unix started?
Well, somewhere probably around 40 years after that, I started trying to get people who actually had the right combination of knowledge and talent and potential interest to write a history of Unix and related things. Because there were several friends who had done basically serious historical studies, and there were other people who had been present at the beginning in a position of authority and influence, and I couldn't convince anyone to do it. So finally I said, okay, let me do it myself. And my wife and I were going to spend 2.5 months in England over the summer, and I thought, well, it'll be a project. And I very quickly came to the conclusion that I was not capable of writing a sort of academic history, the kind that has footnotes and carefully checked sources, all this kind of stuff that just wasn't going to work. And so it mutated into something which was this combination of history and just my personal recollections of things, for which I didn't need footnotes. I could kind of make it up as I went along. And in that sense, it worked pretty well. And I wrote the thing fairly quickly over that period of time in England, and then came back and finished it off. I think the triggering event was that the folks at Bell Labs in Murray Hill wanted to have a sort of 50th anniversary gathering in October of 2019. And that was the forcing function. I wanted to have the thing done and ready at that point. And so I made it within a day or so. There are places where I'm sure a little more seasoning would not have hurt a bit, but that's sort of the genesis and sort of the evolution of it.
That's so did the 2019 gathering that they hope to have, did actually happen, I assume?
That did happen. Yeah, the timing lucked out, and it was quite a nice party. I don't know how many people there, but certainly 300 or 400, and including friends from Unixy days that I hadn't seen for many years.
Wow.
At that point. So yeah, it was actually very, very nice. And they made a video of it, or videotape talks and so on. And some of those are online, and others seem to have disappeared. And I honestly don't know where they went in Bitbucket somewhere, unfortunately. But it was definitely a fun gathering, no question about that.
I definitely intended to read the book. I went to buy it on Friday, but for some reason my Kindle said it wasn't available on my Kindle at the moment, so I'll have to figure that out. And
well, I have you. One of the ways I was able to get it done quickly was to publish it through Amazon's print-on-demand service.
Right.
It's now Kindle Print or something like that. And that has lots and lots and lots of advantages, among others. That you upload the PDF, they look at it, and 24 hours later, it's available. The downside is that it appears, just judging by my personal mail, quality control wanders up and down, depending on all kinds of unknown variables. The copies I've gotten for my own use have all been perfectly good, but others report, erratic printing, poor binding, and it may be partly just dependent on where it's printed, or because Amazon does not use a single printer, as far as I can tell.
Right.
So, and then the other thing is, I should have made a proper Kindle, flowable Kindle, ebook version of it. But the combination of running out of time and finding the various pieces of software pretty crappy, I decided I would go the easy path, which is a print replica, which means it's basically just a PDF. And I don't know why that wouldn't print on or be visible on Kindles. I did it on my wife's Kindle, which is not a new one, and it was okay. And it certainly looks good on things like iPads. So
I have the smallest Kindle, which doesn't do a great job with things like PDFs. So perhaps that's why they said I didn't want to buy it there. Yeah.
Yeah, that's probably the real story.
Yeah.
All right. Could you maybe tell us a little bit more about your experience working at Bell Labs at the time that Unix was first being developed?
Okay, yeah, obligatory rosy glow.
Right, sure.
Reference. It really was a great fun. I had spent, so I was doing PhD stuff here at Princeton in the late, second half of the 60s. And I spent a summer at MIT in 66. And that was a wonderful environment, because that was when they were, CTSS, the compatible time sharing system, was just being upgraded or scaled up to Multics. And so there I was hanging out with a bunch of people who were really, really first-rate programmers doing absolutely fabulous work. And I was living in Cambridge, which was a great place to live. And, all of this was really good, and I enjoyed it. And then there was this cohort of people who I had never met who were at Bell Labs, but because they were part of the Multics operation, but they were all in New Jersey. And so the next summer in 67, I got this job at Bell Labs, working with the same people in the same group. And so that I think was part of why it was so much fun, is I'm working with people who are doing interesting things. And most of them are, well, I shouldn't say young people. Some of the folks like Ken Thompson, Dennis Ritchie, and so on were essentially the same age as I am. So it was fun for 2 summers. I actually had 2 internships, and I had so much fun that I never interviewed anywhere. They offered me a job, I took it, and I went there the beginning of 69. And it was in this relatively small group of people, Computing Science Research Center, maybe 25 people who were interested in things in and around computing. Some of it was algorithmic stuff, some of it was languages, tools, and this underlying interest in operating systems. And so there's all kinds of interesting things in the air, but it was basically a bunch of sharp people playing with computers and having a good time, because it was early in the evolution of computing. And things like Moore's Law was making computers sort of more accessible to groups. For $50,000, which is a lot of money in one sense, but not in another. You could get a decent machine like the PDP-11, which came out, I guess, in roughly 1970 or late 70, early 71, something like that. So part of it was just lots of interesting people and lots of interesting things to work on, and an environment where they didn't tell you what to do. Do something. And so it tended to encourage people to wander around and talk to others and find interesting things to work on. And of course, this was the research arm of AT&T, which at the time was providing telephone service for most of the United States. And so it was a very big company, 1 million people, 1 million employees. And so there were a lot of interesting problems or things to work on. It didn't matter what you were interested in. Somebody in the telephone system probably cared about it. And so that meant that management didn't tell people what to do, but rather tried to dangle interesting things in and around. But they also were perfectly happy to have people work in the academic side of things, publish papers in journals, conferences, things like that. It was all deemed to be good. And so in that sense, it was a lot of fun. You didn't have to worry about funding. You didn't have to worry too much about resources. It was a place where I discovered something I hadn't actually seen much of as a graduate student. People came in and worked at night. And there was sort of, I wouldn't call it a night shift, but there were a group of people who kind of were more comfortable working in the evenings or even far into the night as a group, or, as numbers of individual, but not because of conference deadlines or anything. It's just that they were turned on by what they were doing. And I discovered, gee, it's kind of fun. You could go there, you could work at night too on these intriguing things. So yeah, it was good in that sense. The other thing is, I think there were so many good people doing so many interesting things that it was kind of like, I don't know, playing tennis, which I do really badly. If you play with people who are better than you are, it improves your game. And I think I benefited from that a lot. So imposter syndrome in some sense. But the other thing is, of course, there would be something where perhaps you could be better than all those other folks who were better than you on most things. So, no, it was a lot of fun. There's no question about it.
That's I hear these stories about like AT&T, Bell Labs, and 3M and stuff from the 60s, 70s, and 80s, and I feel like there's just the environment of like pure research for research's sake, like sending people off to go and investigate things. I feel like it doesn't exist in the same way as it used to.
I think that's to a considerable degree true. I mean, in theory, that's what universities do, but
Right.
in universities, you have other pressures. Among other things, most people have to worry about funding. They have to get money for, in particular, supporting graduate students who then do the research that the faculty member would like to do, but is tied up in fundraising. And there are mixed benefit chores. At this point in my life, I very much enjoy the teaching aspect. I don't resent that time whatsoever. But, I remember a friend of mine coming back from a Bell Labs friend coming back from a sabbatical stint at a university saying, those people do research as a hobby. Okay, whereas it was a full-time job at Bell Labs. Mixed blessing for sure. But today, yeah, I think it's harder to find places where people can work on whatever they want without any real immediate concern for whether is that going to pay off in some sense.
Right.
It worked well at Bell Labs in part because of sheer scale. There were a lot of people. Because there was this problem-rich environment, lots of things to work on, and absolutely stable funding, because Bell Labs was funded by, in effect, a tax on telephone services. So if you made a long-distance call, a little tiny slice of that would go off, and that would be part of Bell Labs' budget. But so you could predict what the revenue would be. The quid pro quo was that Bell Labs, as an aggregate, had to do things that in some way improved telephone service for the country. And it worked pretty well for, close to 100 years, or certainly 75 years. And then, various things changed.
So just as a hypothetical, if you had to justify the research that you were doing back then and say, this is the expected payout that we expect to get from this, do you think UNIX would have ever been developed?
I'd say the odds were against that. I think because it was, these guys fooling around. Bell Labs had been involved in the Multics project for 5 or 6 years, I guess. And it was crystal clear that Multics was not going to arrive on time to provide the service that it had promised to provide. Okay. And so Bell Labs pulled out of it. And that left, I think, Bell Labs management at the money-paying ranks, bitten and thus shy of future stuff. And why are you working on it? But management, on average, I think, took a very enlightened view of work that wasn't obvious. I remember once being in a room with Ken Thompson and Joe Condon, who had done this work on Bell, the first really successful chess-playing computer. Okay. And Bill Baker, who was at that time president of Bell Labs, I guess, came in with some August visitor just to show off what kinds of things go on at the labs in research. And said visitor asked, well, why are these guys working on computer chess? It doesn't have anything to do with communications. And Bill Baker gave a 5 or 10 minute discussion of why this was important. Look, they're doing computer aided design, they're building tools, they're better understanding how to make specialized equipment, etc. Wow. So he did the defense so that somebody like Ken or Joe didn't have to say anything. And I think that was really meant too. It wasn't a sort of a PR mechanism. I think they actually meant. So yeah, it wasn't. I think if you wanted to work on the same thing for 5 or 10 years, somebody might say, would you think about redirecting? But certainly it was measured in multiple years, not multiple hours.
What do you think, Rob? Would you go move to a job if you could just spend multiple years researching your passion work?
Certainly sounds like fun, yeah.
I think you'd find, however, if you weren't in an environment where other people paid attention to it and were intrigued by what you did and gave you feedback about it, I bet it wouldn't be as satisfying. I think that was one of the things that worked well at the labs. You would build something. In my case, I would write a program that did something, and other people would use it. And that was very positive. They say, gee, that was neat. I was able to do this with it. And you think, wow, that's wonderful. And then, of course, they tell you about the features that were missing or the bugs they found or whatever. And that wasn't so good, but it was a useful piece of feedback.
I kind of feel like there might be a corollary here to modern like GitHub open source development, where so many times someone will make from their perspective as a throwaway project. They're like, oh, here's a thing, I'm just going to toss it up on GitHub. They stop paying attention for 6 months, and next thing they know, there's 100 people who are all interested in this toy throwaway project that they were last working on.
Yeah,
so
I think
it happens anyhow.
I think that is in some cases absolutely a fine mechanism, and certainly I stumble across things on GitHub from time to time and think, gee, that's kind of neat.
Yeah.
So I apologize for not knowing the timelines, but C and Unix development, but were they developed at around the same time at Bell Labs?
Well, roughly. I can recommend a good book, by the way, in case you want to get the timeline right. Sorry. Yeah, so I think the Unix, the kind of call it the prototype version of Unix, it dates from roughly the middle of 1969. And this is when Ken Thompson did his famous, found a little used PDP-7, and in 3 weeks put together what is really arguably the first Unix system. So he did that in, call it 1969 or something like that, on a PDP-7, which was already an obsolete machine at that point, and quite small. It had 8K 18-bit words. So half was the operating system, the other half was where you swapped user programs in and out. And then I think but that was an assembly language program, PDP-7 assembler, but he wrote his own assembler, of course. And then the first Unix thing that you and I would say, oh yeah, that's a Unix system, was kind of call it the middle of 1971, or maybe a little, somewhere around there anyway, on a PDP-11, which had just about appeared at that point. And that was a richer machine. It had somewhat more memory. I think our first one had 24K bytes, so a little bigger, cost $50,000. But it had types, it had characters, single bytes, and 16-bit integers, which were also pointers. The address space was 16 bits. So the first version of Unix for that was written in PDP-11 assembler, of course. Ken wrote the assembler for that too, along with Dennis, I guess, in some sense. And the third edition of Unix, which came along in, I think, February of 73, was still in assembly language at that point. But C, Dennis had started working on C in, call it 1972, and it's basically taking typeless languages, BCPLB, and converting them into something that had types. Not many types, basically just char and int and address types. And so he was still converting and working on the C programming language at that point. So, but somewhere in 1973, the system was rewritten in C.
Okay.
The thing that was needed was basically struct, because it's hard to do operating system related things if you can't get at the individual bits and pieces of stuff. So the fourth edition, which showed up late in 73, was an assembly language, or sorry, a C program. It was, I don't have the numbers for that one, but by the time the sixth edition came along, which was 75, that was about 9,000 lines of C and maybe 500 or 1,000 lines of assembly language to get at specific things in hardware that didn't fit the C model very well. And that's the version that John Lyons documented in his commentary. So most of the stuff that made the modern Unix was pretty much completely in place by, call it the fifth or sixth, certainly by the sixth edition. And of course, there were lots of things that weren't there because they didn't meaningfully exist. Multiple processors, for example, or networking in its various guises. But you could go back to sixth edition Unix today, and you probably wouldn't like the shell, but because it was not it was programmable, but it wasn't very good. And the Bourne shell came along somewhat after that, and that made it actually possible to program properly in the shell. But pipes showed up, I think, in the third edition. They were first done in assembly language.
That's interesting. You brought up the Lyons commentary, because that was I went to university in the late 90s, and there was I recall it being almost like a legendary book, because at the time, no Amazon, as far as I knew, it was out of print at that time. I believe you can now go buy a new copy. And I heard stories from friends that are like, well, no, what you want is the photocopy of the photocopy of the photocopy that has everyone else's handwritten notes in the margins about Lyons' commentary.
Yeah, right. Sort of Talmudic or something. Hang on one second, guys. I wonder.
Oh, I have a copy.
I just happen to have with me.
Oh, wow.
Wow.
For our audio listeners, he has a copy of the Unix book.
And it's a numbered copy.
Wow.
Number 135. So that's one of the original manuals.
That is the commentary. That is the code, and the corresponding bright orange thing.
Oh, the commentary of the Linux of the Unix operating system. Yeah.
So that's a priceless document, if you like. But I have the other one, and I'm sorry again that this is the one that you're referring to, Jason.
Yes, that's the one I'm referring to. Yeah, the Lyons commentary print version. Yeah.
And I don't know whether that's still in print or not. I bought a copy when it became available, as you say, probably in the 90s sometime. And then somebody some friends in Australia actually gave me a copy of one which is bound differently, but it's the same content quite recently. So it's a absolutely marvelous thing to read if you're interested in.
Those manuals that you just held up a moment ago, do they have your handwritten notes in the margins? Maybe that should be preserved.
I think this one has one thing. You can see little yellow stickies there. And if I open it up to that page, it has somewhere in it, and I can't find it now. It's the other side. It has that famous line that says, "You are not expected to understand this."
Oh. So I mean, back to the UNIX and C coming out. Is it fair to say, from what you just explained, that the point was to write less assembly? That's why C was used more?
Yeah. Oh, absolutely.
Okay.
One of the many contributions from Multics. I mean, it's easy to badmouth Multics, but they had some incredibly good ideas, along with some incredibly good people. But one of the ideas that they had was, let's write the operating system and all of the tools and so on in high-level languages. And so they started out with PL1, which turned out to be an inappropriate choice, shall we say, because PL1 was way too big, way too complicated. Compiler technology wasn't it. Not up to it, I think. And so they converted a lot of it to BCPL, which was a very much stripped down language. It was done by Martin Richards at Cambridge and imported to MIT. BCPL was a typeless language, but very straightforward and clean and simple. And so it showed that you could actually write quite effective systems code for all systems applications in a high-level language. And so the path from BCPL, which of course people at Bell Labs used in their Multics work, then led Ken to build a simple, very simplified version of the already simple BCPL, which he called B. But it was typeless again. And that was the thing that ran on the PDP-7. And then Dennis, retrofitting types into that, made it C. So that's the evolution. But the idea of writing high-level languages, I think, was very much a Multics idea. Whether it came from somewhere else before, I don't know. But once you've done that, then you get all kinds of advantages. And you can see several. One advantage, if things are written in high-level languages, is that it broadens the base of people who can be programmers, because they don't have to know the assembly language. Assembly language programming is picky. It's hard work to get it right. And so you've broadened the base of people who can write code, and that's very important. You've already seen that with things like Fortran a decade and a half earlier. And the other thing, maybe not so expected byproduct, was portability. And first portability of tools that you might build, and then ultimately portability of the operating system itself. And so once the operating system was written in C, people started to think about portability. The first port was done in early 77, I think, by Richard Miller at the University of Wollongong in Australia to an Interdata 732. And then 6 months later, Steve Johnson and Dennis did a port to the Interdata 832. Right? Distinction between those two, I don't even know what it is at this point. Different approaches. I think Miller just transliterated the code, whereas Steve created a portable C compiler, that is a compiler that would run anywhere, that had a code generation that you could tune to different machines. So, and once you've got portability of all of your code, then that has all kinds of benefits, including freedom from depending on particular manufacturers. And so now you can see that. I mean, think of Apple going from the PowerPC to the Intel x86 series to their own M1 design at this point. And that all depends on the fact that they're using high-level languages for everything.
Yeah.
Right. So when you were all working on Unix and it was being moved to the PDP-11, what operating system were you using before you actually were using Unix?
The Unix was self-supporting extremely early. Not the PDP-7, where I think probably the assembler was running on a big computer at the Murray Hill Computer Center, probably a GE 635, which was the general purpose machine that was used there. But very quickly things became self-maintaining, and I think by the time the first edition 1 of the Unix system was there, it was totally you were able to run on yourself, as it were, that there was no dependence on other computers.
Okay.
When did your own involvement in C begin?
Well, my involvement is basically as a popularizer. I wrote a tutorial for B, just as a sort of, how do you get off the ground and write code in B? And I don't even remember why I did it. I mean, but that's one way to learn it. And then when C came along, I basically upgraded that B tutorial into C, and that was more useful. And at some point, it looked like there would be, interest outside our little group in something more. There were probably at that point 100 Unix systems. I don't even remember. And so I twisted Dennis Ritchie's arm into writing a book with me on C. I don't think he originally wanted to do it, but being a nice guy, he did. And so that was probably the smartest thing I ever did in my life, because I really wanted his expertise and I wanted his reference manual. And so So he and I wrote the book together. I wrote the first draft of a lot of it, but the reference manual is entirely his. I don't think I ever touched a word of that.
Okay.
And he did the system call chapter because he knew that stuff better than I did. And then we homogenized the earlier stuff. So no, that worked out rather well. I'm not always that lucky.
You were the chief evangelist for C.
Not in any intentional sense, but it sort of worked out that way, and at least in some sense.
Right. So how did you all, you said at that moment, you estimate there were maybe 100 systems running Unix. Like how did this sharing of knowledge and software proliferate around the world in labs and stuff at that time?
My memory, and this is not something that I was deeply involved with, but there was, first, Unix spread inside Bell Labs because it provided an environment for lots of the support systems that went into running, a nationwide telephone service, keeping track of where is equipment and who's paying for what, and, all kinds of reports of one sort and another. And it turned out Unix was just better for that kind of thing. And there was a version of Unix internally called the Programmer's Workbench, which built tools that made it possible for people with big databases and big record keeping requirements and big logging and real-time control and all kinds of other things to use Unix, just basically to interact with other stuff, whether big mainframe computers or weird peripherals. So there's a lot of spread inside. And at some point, it got enough press, and maybe it was because of the CACM article in whatever it was, 73 or something like that, that universities started to ask whether they could get copies of it. I think Ken Thompson took a copy with him when he went to Berkeley on a sabbatical, roughly that time. And so universities started to get it, and AT&T, I think, didn't know what they were doing. And furthermore, had trouble. They couldn't sell software because they were a regulated public monopoly.
Right.
They couldn't sell software because somebody could accuse them of cross-subsidizing the telephone business and thus giving, who knows, some unfair advantage to something. So they couldn't sell it, but they could license it. And so what they did was to license Unix, the source code, as well as the running system, to universities for what amounted to a nuisance fee, $100 to make a magnetic tape or something like that.
Okay.
And so that proliferated, and people with the licenses to do this interpreted the license, at least, as saying they could talk to other people who had the licenses. And so they formed user groups where people would get together and they would discuss what they were doing, and they would swap their code, kind of like an early version of open source GitHub-y kind of thing, with 9-track magnetic tape. And so they would, have these meetings, which became essentially the Unix users group kinds of meetings that proliferated around the world, national groups in lots of countries, and led to conferences like the UNIX conferences that still go on to this day. I guess, or maybe they're Linux conferences at this point, but that was the spread mechanism. It was mostly through universities. There was a commercial license that was also available for 20,000 sticks in my mind. And so you were a company, you could buy a Unix license and become part of this group of people who could share their expertise in this weird system. And so that took us through probably the 70s very nicely. One of the centers of activity was Berkeley. Ken had been an undergraduate and a graduate student at Berkeley, so he had lots of friends there. He taught there. And at some point when the VAX came along, which was the 32-bit version of the PTP-11, when the VAX came along in the late 70s or something like that, I think the center of gravity shifted to Berkeley, and particularly with the networking kinds of things, because all of the internet code that was written for Unix was done there originally by Bill Joy and colleagues.
It's a mental picture that I've just never considered before, of someone literally carrying a 9-inch magnetic tape. I just got the latest version of Unix. Let's install it.
Yes, right. And it's 9-track, not 9 inches.
Oh, 9 inch. Sorry. Yeah.
Because there's a bit of a generation gap here or something.
Yes. I'm older than Rob, but the oldest media that I've used is 5.25-inch floppy. Oh, I've used tape. I've used audio cassette, compact tape
Right.
as well.
I even have an 8-inch floppy around here somewhere.
Do you still find yourself using Unix, or as your primary operating system something else?
Yeah, I think so. My personal computers are almost entirely Macs, a combination of portability and just ease of use. And so arguably what I'm running there underneath is a flavor of Unix.
Sure.
It's based on some BSD thing, much mutated, I guess. And so I think of that as Unix, and I'm sitting here, I've got terminal windows open and so on. The university, certainly the computer science department, runs Linux. I've forgotten which flavor, doesn't matter. And so I often use that, basically SSH into, a Linux system. And I kind of don't care which it is, because most of the things I use kind of work the same on all of them. And if they don't, I think of it as a failure of implementation or something like that. So yeah, I'm basically just using Unix as I always did.
Cool. That's amazing.
Going through your list of publications that you've worked on over the years, in addition to the C book and the recent Unix memoir, you also worked on a Go programming language book. I was kind of wondering what your involvement was in there.
Yeah, that was done with, and I think the correct preposition there is actually by, Alan Donovan.
Okay.
I had spent summers at Google off and on for quite a while, and some accident of geography and knowing people, I wound up sitting in the group of people who are working on Go at Google in New York. And Peter Weinberger, who's an old friend from Bell Labs Day, was there, and next desk was Alan Donovan, who I had not met before that. And so Alan and I talked, and I did I was his intern in effect for one summer, and I learned some Go at that point. And everybody I talked to, including Alan, including Rob Pike, who was one of the creators of Go and so on, said that they didn't like the existing repertoire of Go books that were out in the world. And Alan and I decided that maybe it would be worth trying to write a book about Go. And so we did. But the book is probably 95% his work. I mean, he's just an exceptional programmer and in addition, an exceptionally good writer. And so it worked out extremely well again. And I didn't contribute nearly as much as he did. So, but that's the genesis. And so I don't write very much code, period, not as much as I would like. It tends to be small things, and I haven't written any significant amount of Go in some years at this point. So it's one of those things I would love to get back to because it's a nice language, and but I'd have to refurbish my knowledge.
Curious, excuse me, in your experience as a professor, because I understand, right, you became a full professor in 2000, if that's, for about the last 22 years now. You've seen students who, personal computers were, not everyone owned one, to everyone like literally carrying a computer in their pocket. Like, have you seen, do incoming freshmen know more or less today about computers than they did 20 years ago? Or have you seen any kind of shift or change in what the average student coming in?
Yeah, it's an interesting question. I think what I would say is, it's not that they know more or less, but they know different in some sense. The kinds of things that I would have taken for granted that, well, first, two populations. If we pick the kids who are going to wind up in computer science, I think today they are operating at a higher level, if you like. They tend not to know actually how machines work, and they're not as good at, let's say, what I think of as absolutely core Unix tools. Like I know all of those weird abbreviated names, and they don't. And I know the totally irregular, weird set of arguments for lots of commands, and they don't. And so I can do things at the command line that they can't. But the flip side is that they're a lot more comfortable at other things, higher level languages. A lot of them are comfortable in Python. They learned Java in high school, maybe, or pick it up quickly here. Just so they know different kinds of things. Just a random example. I was sitting at home in one of the perpetual Zoom sessions with one of my kids last week, and my connection was really lousy. And I said, "Oh, the ping times, I can see the ping times are going up." And he said, "What's that?" So that in a way encapsulates it. And, a very, very bright kid doing really interesting work, but at a high level, and he didn't know what ping was. So, but there's a different population as well, which is kids are not admitted to computer science at Princeton. Some schools they are, you apply computer science or you apply whatever, but here you're admitted. And so that means that kids come in and they discover computing by virtue of taking a course early on. And then they say, gee, that's a lot of fun, but they didn't do any computing in high school.
Right.
And so those kids, ultimately, that first course kind of brings everybody up to a pretty much common level, even though some of them have never done any computing before. And so that means there's a population of kids whose length of experience and perhaps breadth of experience is just different than it might have been 20 years ago. But that isn't to say they won't be very successful if they decide to go on in computing. And the flip side, of course, is that pick your discipline. I don't care what it is. It has a computing component at this point. It
Right.
really does. And so any field at all that you might want to work in, you're going to need to know something about computing if you want to be kind of up to date with what goes on in it. And that's one of the reasons why I'm doing this digital humanities course. I'm talking to historians and English professors and art people and so on, and they use computing in their work. So a lot of the kids who take the intro computing courses here are not going to be computer science types at all.
Right.
Yeah.
Thank you.
Yeah. Well, Brian, it was so great having you on the show today. Thank you so much for going into all this history with us. Thank you so much for coming on.
No, it's great fun.